Hello everyone, welcome back to my channel. So in this lecture we will see reduction formula 7, that is the reduction formula for sin raised to m into cos raised to nx dx. So this is the formula I have written. So let's prove this formula. So what we will do is we will assume that im comma n be equals to integration of sin raised to mx cos raised to nx dx. Now we have to prove that this equals to the right hand side of the formula. Okay, so for that what we will do is we will break this sin raised to m as sin raised to m minus 1 x into sin x and cos raised to n as it is. Okay, now to this we will apply the integration by parts. So we will treat this as first function and this as second function. So apply the integration by parts. So what it says, first function as it is, integration of second function. So this is my second function. I will write it as cos raised to n sin x dx minus integration of derivative of the first function. So derivative of sin raised to m minus 1x into integration of second function, that is cos raised to n x integration of second function, that is cos raised to nx sin x dx. Okay, so what we want basically here is this integration. So what I will do is I will evaluate this integration separately, that is integration of cos raised to nx sin x dx. Okay, so we will evaluate this separately. So in this integration what I will do is I will put cos of x is equals to t. Okay, then what will happen to the derivative? Cos ka derivative is minus sin x dx equals to dt. We will use this substitution here in the integration. So this implies integration of cos is t, so t raised to n, sin x dx will be equals to minus of dt. So I'll pull this minus sign outside, dt. So let's evaluate this integration. Minus sign outside, integration of t raised to n is t raised to n plus 1 upon n plus 1. So what I will do, again I will substitute back the value of t. So t is cos, so this gives me cos raised to n plus 1x upon n plus 1. So this we have evaluated. So integration of cos raised to nx into sin x dx is nothing but minus cos raised to n plus 1x upon n plus 1. So let's put this value here in the previous step. So what do we get here is sin raised to m minus 1x. Value of this integration is minus cos raised to n plus 1x upon n plus 1, then minus integration of. So let's evaluate derivative of the first function. So derivative of first function here will be m minus 1 will come in the front, power will get reduced by 1, okay, and then derivative of sin x is cos x into integration of this second function. So integration we have already calculated here, it is minus cos raised to n plus 1x upon n plus 1 and then dx. Now in the next step what we will do is we will simplify everything whatever we have written. So here we have minus sin raised to m minus 1x cos raised to n plus 1x upon n plus 1. Then this minus and this minus will become plus sign here. Then I will pull this m minus 1 outside. Then from the denominator I will pull n plus 1 outside. In the integration sign we have here sin raised to m minus 2x. Then cos into cos raised to n plus 1 will give me cos raised to n plus 2x dx. Okay, now next step. First term will remain as it is throughout now. It will remain as it is upon n plus 1 plus m minus 1 upon n plus 1. Now what I will do is I will break this cos raised to n plus 1, n plus 2 as cos raised to n into cos square x dx. So you just break cos raised to n plus 1, n plus 2 as cos raised to n and cos square. Okay, and then in the next step you replace this cos square by 1 minus sin square x. So this will imply the first term as it is, second term is this integration sin raised to m minus 2x cos raised to n x, and replace cos square by 1 minus sin square x dx. Now next step is, we have here sin raised to m minus 1x cos raised to n plus 1x upon n plus 1 minus. So this term will remain as it is throughout. Okay. Now next step is m minus 1 upon n plus 1. Then you just open the brackets. So that gives me sin raised to m minus 2x cos raised to n nx, and then minus we have here sin raised to m, because we have sin square in the previous term. So sin raised to m minus 2 into sin square will give me sin raised to m, then cos raised to nx. So what we have done is, you just open the bracket first, and then in the next step you separate the integration sign. So here we have sin raised to m minus 1x cos raised to n plus 1x upon n plus 1 plus, now you open the you just separate the integration sign. So we have here m minus 1 upon n plus 1 integration sin raised to m minus 2x cos raised to nx dx, then minus m minus 1 upon n plus 1 integration sin raised to mx cos raised to nx dx. Now let's put this integration in terms of the notation that we have used. So we know that on the left hand side we have I m comma n. So it is basically the integration of sin raised to m into cos raised to nx dx. So I m n we have on this side. Now this term as it is, then plus m minus 1 upon n plus 1. Instead of this we will write down its notation form. So I m minus 2 comma n, because instead of m we have m minus 2 here. Then minus m minus 1 upon n plus 1. Instead of this we will write down the notation. It is I m comma n, because we have m and n here. So that's why I m n is the notation. Now if you see, on the right hand side we have I m n term, on the left hand side we also have I m n term. Okay, so let's bring I m n term together on one side. So let's shift this term to the left hand side. So this gives me I m n minus will become plus this side, m minus 1 upon n plus 1 I m comma n is equals to, now the remaining term as it is on this side. I m minus 2. Let's simplify the term which is there on the left hand side. So this gives me, if we simplify this, so this gives me 1 plus m minus 1 upon n plus 1 I m comma n. The terms on the right hand side will remain as it is. M minus 1 upon n plus 1 I m minus 2 comma n. So if I simplify this, it will give me n plus m upon n plus m upon n plus 1 I m comma n. the terms on the right hand side again as it is. M minus 1 upon n plus 1 im minus 2 comma n. Now we just want im on the left hand side. So what we will do is we will divide both sides by this term, that is n plus m upon n plus 1. So when we divide both sides by this term, this n plus 1 term will get cancelled. Okay, so we are left with what? Sin raised to m minus 1x cos raised to n plus 1x upon n plus m plus m minus 1 upon n plus m im minus 2 comma n. So this is reduction formula 7. If you want, you can write down this reduction formula in terms of integration. So it is basically what? Integration of sin raised to m into cos raised to n x dx is equals to minus sin raised to m minus 1x cos raised to n plus 1x upon n plus m plus m minus 1 upon n plus m integration of sin raised to, now here we have instead of m minus 2x cos raised to nx dx. So this is basically the reduction formula 7. That is the formula based on sin raised to m and cos raised to n. So this is the end of the proof of reduction formula 7. Thank you for watching this video. Stay tuned for the more videos on reduction formula.